And this video is going to be talking about to finding the derivatives of functions. Now, in differentiation, we have rules. First of the rules that I will be taking you with will be power rule. Power rule. I will take you through power rule. Now, if you are asked to find a derivative of a particular function and you are using power rule to find that derivative, take for instance, in power rule we have a formula d all over dx x raised to power n. When you want to find the derivative, you are going to bring n x n minus 1. This is how to find the derivative of this particular function. So let's take for instance, you are given, let's say, to find the derivative of this particular function d all over dx, find the derivative of x raised to power 2. Now, to find the derivative of this very function, you take that 2 to be n. So you say, you bring down 2n, then you say 2 minus 1. You see? Therefore, we will say 2x raised to power 1. This is our final answer. Exponent, please. Find the derivatives of, let's say, d all over dx. So you find the derivative of x raised to power cube. How we did earlier, you bring down the 3. 3 is representing n. X 3 minus 1. Therefore, we have 3x raised to power 2. What if you are having, you are asked to find the derivative of n raised to power 4? So you say differential of dx, d all over dx, x raised to power 4. So we have 4x 4 minus 1, where we now have 4x raised to power 3. We have another one. Let's say you have, this one looks a little bit different. You have d all over dx. We are finding the differential of just x, right? Now, you know, whenever you see something like this, always have in mind that there's an invincible one sitting right on top here. Therefore, to go ahead with this, you are going to say that one, you are bringing out the 1. You understand? You are bringing out the 1. So let's say you say 1x 1 minus 1, which is going to be what? 1x 1 0, right? Now, you know, anything raised to power 0 is 1, right? So 1 times 1 will still be 1. So therefore, our answer will be 1. So let's say we have another question. Find the differential of d all over dx. We have 5x. Now, to find the differential of this particular function, we're going to say, first of all, you look, we're having a constant here and just x here. You can as well move this constant to the front. Then you go ahead and find the differential. So you can as well move the constant to the front and go ahead and differentiate. That you move this 5 here to the front here. And when you move it to the front, what you are having will be d all over dx. You put 5 here. So x now, you know the differential of x, like we said earlier, is equals to 1. 1 times 5 is equals to what? 5. Just like 5 times 1 is still 5. Now, what if you have a differential? A differential of, let's say, d all over dx. You have minus 7x equals to minus 7. How do we got to arrive at equals to minus 7? I just wanted to speed up why this is just almost the same thing here. We move this 7 to the front. Therefore, we have d all over dx minus 7. The differential of x, we know it to be 1. 1 times minus 7 is equals to minus 7. That's how we arrive at that minus 7 there. So what if we have a differential of d, a differential of d all over dx, then we have 8, just a single constant. Then I tell you the differential of any constant is equals to 0. Another example, let's say we have d all over dx, then we have 9x raised to power 4. Find the derivative of this particular function. To find the derivative, we are going to say 9 multiplied by 4x4 minus 1. You understand how we did it? 9, you can move 9 to the front here, right? You can as well just move 9 to the front here. Then you say bring down 4, because 4 is representing n. You bring down 4, then you do 4 minus 1. So now whatever is in the front here, immediately you do the differential. It's going to multiply by the result of the differential, the derivative, right? Now you say 9 multiplied by 4 is 36. Then we say x now, x raised to power 4 minus x minus 1 is x raised to power 3. So this is going to be our final answer. Let me use this place here also. Let's say we have another particular question. We have dx, ddx. We are finding the derivative of this particular function, 7x raised to power 5. Now, on the derivative of this function, we have 7. We are multiplying it by, you can just put it in the bracket if you want to be more clear so that it will not be confusing to you. 7 multiplied by 5x raised to power 5 minus 1. Right? Now we have 7 multiplied by 5 x raised to power 4. Then we have 7 multiplied by 5 is 35. X raised to power 4. This is our final answer. Next, we are looking at finding derivatives of polynomial function. Now, before us here is a polynomial function. This is a function. To find this the derivative of this function, first and foremost, you are going to differentiate them individually. So therefore, to go about this, you put your equals term here. You say 5, you put 4, open bracket, 5x, 5 minus 1. You put plus 7, open bracket, 3x, 3 minus 1. And you put minus 9, 1x, 1 minus 1. Then the derivative of a constant we said earlier is 0. So it's going to be plus 0. Now to resolve this particular derivative, we put 4 times 5 is 20. X raised to power 4 plus 7 times 3 is 21. X raised to power 2. Then minus x raised to power 0 is 1. 1 times 1 is 1. Minus 9 multiplied by 1 is minus 9. So this is going to be our final solution. Now, what if you want to find the derivative of a square, right? So let's say we have d dx, and we have a square root of x, square root of x. Now to find the derivative, first thing first, we have to rewrite the distance. And by the way, sometimes when you are given square root, there will be no 2 here. So long as it's a square root and there is no 2 here, just have anything in the back of your mind that there's an invincible 2 here. Now the square root of x, right? Therefore, we'll rewrite this particular function. To rewrite the function, we'll say d all over dx. We have x raised to power 1 all over 2. Now, because there's an invincible 1 here and there's 2 here, you put 1 all over 2. Then you go ahead and differentiate. Now, to differentiate for this particular function, we say 1 all over 2 x 1 all over 2 minus 1. Now, we want to find 1 all over 2 minus 1. So we'll put 1 there. We'll put 2. 2 divided by 2 is 1. 1 times 1 is 1. 2 divided by 1 is 2. 2 times 1 is 2. So we put minus sign, put 2. Therefore, our answer will be what? Minus 1 all over 2. Therefore, we say 1 all over 2 x minus 1 all over 2. Now, another thing you should pay attention, whenever you see the exponent is carrying a negative sign, you try to eliminate that negative sign. And in this case, how we do that is by moving the whole of this moving the whole of x downward. So we say 1 all over 2 x 1 all over 2. Got it? This is how you put it. Now you can as well write this particular, to write it and make it look better. You can put 1 all over 2 square root of x. This is another better way to rewrite this particular function. Right? Now let's take another one. Now let's try another radical question. You see, we've solved one radical question and now we're having another one too. We'll still follow the same pattern. We'll rewrite the whole thing. To rewrite the whole thing, we'll say, rewriting the whole function, we have d all over dx. Then we say x 4 all over 7. This is how we write the whole function. Now, to differentiate this function, we are going to say 4 all over 7 x 4 all over 7 minus 1. Now, what we are trying to do is 4 all over 7 minus 1. Bring down 7. 7 divided by, what we'll have is now going to be 4 all over 7 x minus 3 all over 7. Now this, because our exponent is carrying a negative sign, we can rewrite this particular function to be 4 all over 7 x 3 all over 7. You can as well write it as 4 all over 7, the 7th root of this is 7 here, please. The 7th root of x raised to power 3. This is how we write the final answer. Our final answer will be 4 all over 7, the 7th root of x raised to power 7. We did the radical functions. Now we want to look at a rational function. Now in this particular rational function, to find the derivative, we are going to what? First of all, rewrite it again. So now in this case, to rewrite this particular function, we say d now all over dx. X is, when you are rewriting this function, I want to carry this x upward, so it carries a negative sign now. So when you carry the x upward, it carries a negative sign, minus 5. So to differentiate this particular function, we say minus 5 x minus 5 raised to power minus 1, right? So minus 5 x raised to power minus 5 minus 1. Therefore, our height will be minus 5 x minus 6. Now, this would have been our answer, but because x is carrying a negative sign on as an exponent, you rewrite this place. Write it as minus 5 x raised to power of 1 6. Now, this will go up. Therefore, finally we'll have minus 5 x raised to power 6.